Hey everybody, if you're new here, my name is Jake, and today we will be building a smart camera system. We're going to be doing that with a Raspberry Pi, and the reason that we can use such a small Raspberry Pi computer is because most of the processing is going to be done on the camera itself. So we'll be using a Luxonis camera. I'll be using the Oak One, but I think any of these would be fine. Some of these have like stereo vision so that they can sense depth, but that's not really necessary for our application. So I'm using the Oak One. They do have cheaper versions, but regardless, this camera itself has chips on it that can run the machine learning algorithm in the model. So the model itself won't actually be running on our Raspberry Pi. It'll run on the camera, and then it will send us back the metadata and image information. So that's exactly what I have here. This is just a little photo of my setup. Here's the Oak One, and I'm using a Raspberry Pi 4. That's just what I have available to me. And it's pretty straightforward. It's USB plug and play. So I actually have it plugged in right here next to me. So you can get started off their website by downloading the libraries. And this is just a slightly modified version of their Get Started script. And when I run it, we get this little view here, and this is coming from the camera now. When I aim it at my face, it says person, and I can turn it around, and we can see that it's sensing a bottle and another bottle. If I point it at the screen, it'll sense TV monitor. So this is just the basic model that comes out of the box with the Get Started script, and it can sense like 20 things maybe by name. You can expand to different models like Tiny YOLO and other things like that. You can even package your own models to put on here. But the basic mobile net is sufficient for what we're doing. And really, we're just going to be trying to sense people and vehicles because we're going to be making a security camera. Okay, so now I'm going to go take this setup and go mount it outside, and then we can take a look at some real data and try to go from there. All right, so now I've mounted the camera in the window facing the front of my property. But I live in a pretty high traffic area, so there's lots of people coming and going across my street. There's people walking and things like that. If this was just a normal security camera that was triggered by motion, see a car just went by, then it would be recording all the time. Every time somebody walked by my property, the motion would kick off and it would start recording again, which I don't really want to do. I only really care if somebody comes onto my property. So what I want to do is basically draw a line from this camera across the field of view so that these detections, like this car that's passing by right now, don't tip off the recording. And really, I only wanted to start recording when the detection bounding box, the bottom of it really, is inside these bounds. Okay, sorry, my mic failed. But what we're going to be doing is in the script, we actually get the coordinates of the detection from this frame norm function, which returns it as a pair of XY coordinates for the top left corner and the bottom right corner of the box. So all we need to do is just add a conditional line here that just says if the Y coordinate of the bottom right corner of the box is more than 190, then the bottom right corner of the detection box is within our bounds. My use case is pretty straightforward because my property is just a straight line in the camera. So anything that's in this area or more than 190 on the Y scale is going to count for me. It may be more complex if you're trying to, find motion within a triangle or a different shape. But in any case, we only process the detections if they're in this range. So now we shouldn't see any vehicles go by. Their detection shouldn't show up because they wouldn't be in bounds. However, if I go walk out there, then, it should pick up me as a detection. So, yeah, let's go test it, I guess. Okay, did that work? So as you saw, there was multiple cars that went by and it didn't show a detection box, but when I pulled in or pulled out of my property or when I walked onto my porch in front of the camera, then there was a detection. So moving forward, the next thing we need to do is actually record this. So this is where we slightly do deviate from the startup script. So I will kind of go through, not line by line, but so in our code, we need to create a new node called the video encoder node. I will put a link to an example that uses this node in the description. But more or less, we're going to create a video encoder node. We are going to create an out for it, and we are going to link the video property of the color camera RGB to the video encoder output. I'm not a Python master. There's probably way better ways to do this. But I did create a frame counter. So how this is going to function is that every time we see a detection that we want to record, I'm going to add 10 frames. And so basically what this solves is it adds a buffer. So let's say I walk in front of the camera and then I walk away out of the camera. When my detection stops, I want the camera to keep recording for an extra couple frames, up to about 10 seconds. So I created this buffer that essentially increases the frames to record until it hits a certain limit, and then it doesn't increase anymore. So the way that's implemented is just this counter here. And then in our function, in the detection section here, again, we have this conditional that I discussed, but here we have a record until, which is a timestamp, and this is actually not what we want to be doing. Okay, after a little bit of Jeopardy music. Anyway, what we wanted to do is just check if there are detections, if we have frames left, and if the detection that we found is in our range, then we want to add frames to the buffer. And then if we have frames left and we have data we can record, then we subtract one of the frames and we put that data into our video file. I'll put this whole script on GitHub so that you can access it if you want. I don't really like doing line by lines. But what this is going to do is it's going to write a video file into our directory here that the code is running in, and it'll write it in H.265 encoding, which is just an encoding format that lets us save on space, I guess. So we can convert it with FFmpeg into an MP4 or another file type if necessary. So what I'm going to do now is I'm going to run the script, and then I'm going to let it run for maybe 20 minutes, and then I'm going to go out there and walk occasionally. And what we'd like to see is that the only recorded footage is when detections are in the range. Other than that, we shouldn't get any recorded footage. So I'm going to go ahead and start it, and then we'll be right back. Okay, so this has been running for, I'd say, about 10 minutes. And as you can see, lots of cars have been passing by. But we've only recorded about 660 frames. So if I go ahead and quit out of this, we can see that we have the H.265 file written. So what I'm going to do is convert that to MP4 with FFmpeg. Great, so now we have our video. So instead of having 10 minutes of footage, we should just have some very nice 4K footage. And here is me watering my grass. So there you go, 4K footage of me watering my grass, and everything else was cut out. And there I am walking away, and the video's over. So we could obviously increase the buffer so that we could maybe have more footage when things are coming in and out of frame. Since that was cut kind of short, I have a pretty short buffer set, but I think for the most part, that's pretty much the recording. The recording aspect is finished. It's in a bounding box. We could even go further and filter out what kind of detections we want to trigger. For example, if we're only looking for cars and people, or if we're only looking for bikes. In my case, I figure anything is fine. I might actually want to filter out animals and things like that, so that like if a dog runs through my property, it doesn't trigger the camera, because I wouldn't really care about that. So yeah, I think that's it for this video. I think in another section, I'd like to see what we could do about making this work at night. Another thing would be multiple cameras instead of just one. We could also explore different kinds of cameras. But I just wanted to give this a try because it sounded like a fun little project, and I wanted to show everybody it could be done. So that's it for me. Thanks for watching.